Railways. Yeah. Actually, Indian Railway doesn't need any introduction. I mean, it is the fourth largest rail system in the world. It transports almost 22 million passengers every day. It carries an originating freight of almost 4.2 million tons. And to produce this transportation output, it runs almost 10,000 passenger trains, around 12,000 freight trains, and deploys assets across its entire 130,000 track kilometers, around 3.5 lakh coaches, freight cars, 60,000 passenger coaches, deploys almost around 15,000 locomotives. Now, just think back and see as to how this gigantic system is managed and administered. Prior to 1986, this was administered on a pure manual mode. And it is a single administered network. We are unlike, say, the US railroads, which have geographically carved out the administrative zones. But Indian Railway is managed as a vertically integrated organization with a single management. This is a question probably you need to answer, and we have been managing railways prior to 1986 when computerization started, and managing it manually. Similar to air traffic control, which controls the entire 3.5 lakh square miles of Indian airspace, railways too are carved into geographical areas where an air traffic control, say around 5 air traffic controls, control each of the geographic space and are responsible for both operations and safety within that geographic region. Railway 2 is administered through geographically administered zones called zonal railways. And these zones, roughly around 16 of them, which each of them have around 5,000 kilometers, are again subdivided into something called divisions, which are around 1,000 kilometers in terms of the stretch. Similar to air traffic controllers, railway has something called section controllers who control the movement of the trains in a jurisdiction of 200 kilometers each. How that happens is a section controller is located centrally in one location, and thereon, along the stretch of 200 kilometers, you typically have around 25 to 30 stations. And each station has a dedicated communication network with the controller. Prior to computerization, as the train charts its path in time and space, the station would repeat the timing at which the train would actually pass the station. For example, if some of you have traveled by train, I'm sure all of you would have, say a train, say Shatabdi Express from Delhi to Amritsar, past Ambala at 3:24, 3:25. A section controller would physically take a pen and pencil on a time and distance chart, plot the movement of the train. And he would control the movement of freight trains on the same chart, similar to control charts what are there in industrial setups. All this changed in 1986 when the first computers were introduced in Indian Railways, and an organization called Center for Rail Information Systems has been created. So this organization's mandate was to design, develop, deploy, maintain the entire IT applications as well as the attendant infrastructure for the railways. For the first 2 decades, we were mostly concentrated on 2 applications. One is the passenger ticketing, the second is the freight operations. And passenger ticketing has evolved over a period of time. If you look at the time scale in which the IT applications on Indian Railway have evolved, you would find from 1985 to almost 2005, we have the ticketing system which has evolved continually. And for many of you who are in that era, I can't find many people of 1986 still remembering the railway at that time. We used to have 4 data centers at different places, all disconnected. And for example, we had a data center at Chennai, we had a data center in Mumbai, Calcutta, and Delhi. And you could take a ticket from any train originating within that region. Say, for example, if you wanted to take a ticket from Chennai counters, say from Delhi, you could not. So later, somewhere in 1990, we totally meshed the data centers with total redundancy, and anywhere to anywhere ticketing started. And somewhere around 2005, we started web ticketing, and then later mobile ticketing, and the latest is further undergoing a revision in terms of getting this ticketing load from which used to be around 1,000 tickets per minute. Now today we issue tickets almost at around 25,000 tickets per minute. And come this August 25, that will go up to around 2.5 lakh tickets per minute. So this continual upgradation is something which is, you can call it a transformation over a period of maybe around 38 to 40 years. Not only the core ticketing systems of passenger reservation and unreserved, our operating application, as I mentioned, the freight operations information system has started somewhere in 1998, and then that too evolved. The first 2 decades were mostly on these 2 applications, but as we stand today, there is no function in the railway which is not digitized and getting into a database. So we, like any other organization, we have our asset applications and asset management applications. We categorize asset management into fixed infrastructure and rolling infrastructure. The fixed infrastructure for us is the track, the traction, the signaling, and the telecom and the electrical equipment. And the entire asset cycle, right from induction of an asset through its repair and maintenance cycles till it is actually condemned, is totally automated in terms of the data and the date and timestamps of the activities getting into a database. Similarly, for the coaches, the wagons, the locomotives, the entire asset cycle has been digitized, and now it is running through our applications. Not only that, our finance, HR, and procurement systems, we handle almost around 2 lakh crore of procurements on our own independent procurement system. And similarly, we transact revenue and capital expenditure of almost both combined around 6 lakh crore on our financial systems, which are robust. So that being the scale, let me also tell you that many of you must have observed both the strengths and the weaknesses of such an evolution. Can someone tell me what could be a weakness the way in which we evolved? Yeah. The issue is no one has actually thought of this starting in 1986 as an enterprise architecture or all the functions combined. As they evolved over a period of time, these applications have evolved as discrete systems with integrations being built into hitherto existing systems. And what is the greatest strength? But as we stand today, there is no activity in the railway which is not getting into a back-end data which can be used not only for day-to-day operations, but I don't think any other organization is as much capable of producing AI applications as railways is because of the historical data we have. And having said that, these applications are developed by CRIS, and one of the greatest strengths of CRIS, Center for Rail Information Systems, which develop these applications and runs, is we do not have any private software developer. We have our own engineers who are around 950 plus core engineers whom we earlier used to recruit through CDAC. Now they come through the gate and keep the systems moving. And one of the greatest advantages of this model has been almost like a seamless upgrade. We don't look behind our back for any change request. It just happens seamlessly. There is a requirement, things get done. So that being the case, the greatest weakness in the entire evolution has been the way in which the discrete systems have been followed and which need to be addressed. in the next few minutes, I would like to take as to what are the steps we are taking to ensure that we actually have a rock solid core in the back end, despite the way in which we evolved. As I mentioned, CRIS, or the Center for Rail Information System, exists only for the Indian Railways. I mean, we cater to the entire IT applications as well as the infrastructure. We have 6 data centers with 1 disaster recovery center in Secunderabad. We almost have around 13,000 servers across the entire Indian Railway, and we have both physical lines and for all the web applications we have 2 gateway systems. One for the passenger ticketing, which is dedicated, and the other one for all our web applications through the other internet gateway. We actually look ourselves as some sort of an enterprise which works within a context of the Indian government. I mean, for example, this is our strategic governance framework for the IT applications. What is the country's goal in terms of going from a particular GDP? What are the various sectors which need to contribute to achieve this particular growth from 2.7 to say 5 trillion USD? And where can you see railways here? Railway is one amongst these 41 sectors, and railway has been given certain goals. And for delivering on these goals, there are certain core objectives which the railway has been given, and there are certain objectives and goals of other sectors which are relevant to us. We are not independent of, say, for example, we are not independent of how the port sector grows, how the coal sector grows. So essentially, and the aviation sector, for example, I mean, we chart down as to what are the goals of the other sectors, and now actual comes the work as how do we do in the strategic positioning of the railway. We look at ourselves as to what applications we have in each of these business categories. What do we have in terms of the business development category, the operational efficiency, the capital expenditure, as well as the management practices and the people, and we classify the applications. For example, we first listed out as to what do we have to serve in achieving the goals of the railways. What applications currently do we have? I mean, acronyms are, customized to the railways, but most of it is, say for PRS is the passenger reservation system. So this is the starting point for us to look at where we stand in terms of delivering a holistic approach. Thereon, we try to find as to what are the functional gaps, where are the applications, which are these business functions which you do not cater at all. And then we listed out as to, okay, these are the gaps, and we need to work on that. Second is to find out not only the functional gaps, within the existing applications, are there any process gaps or anomalies. So we look at it in a bit more holistic manner. We look at as to what are all the gaps in the entire processes, and then try to, notwithstanding the enterprise service buses and the APIs what we have, there are a number of process gaps which need to be filled. And another important thing is all this information which is acquired into our systems, the data acquisition, which was hitherto manual, now more and more sensors and real-time information starts flowing. In fact, if you look at it from the passenger services, you would find that the handheld terminal or the TT replaced the charts. So we have burnt up bridges in terms of not having anything to do with the manual systems many a time. So that becomes mission critical. And not only in the passenger reservation system, even our core operations. I mentioned to you about the time and distance which we used to plot and then do. Now the timing is acquired through our GPS system which we installed on all our locomotives. With ISRO, we have undertaken a project of installing every 30 seconds a GPS system which actually fires into our databases and then charts the path of the train. And this timing is not only used for controlling the trains, but also for firing your national train enquiry system. So this is, And even in the asset management, take your track. Earlier, a lot of measurements used to be going into managing your track, taking your measurements, measuring the gradients, measuring the cross levels, measuring the unevenness, and all this is now coming through highly sensorized systems. We already have an ultrasonic flaw detector machine, we have a track recording car, we have an oscillation monitoring system, and as it runs kilometer wise, it gives you what is the riding quality in terms of the G value of at that particular value. All this gets into the backend database for us to manage our systems. So the fundamental nature of as to how the data is being acquired and how you interface with their existing systems is something which needs to be addressed, especially for legacy organizations which are evolving over a period of time. If you are totally a greenfield organization and coming with an application, you start from maybe the state of art. But you need, when you're an organization which is a legacy, you need to take into account how do you transform yourself from the existing. This I already mentioned. I mean, it should have been the other way around, where all the process deficiencies are listed. And in the evolution, there is another major problem. Because of the discrete applications which are come over a period of time, the management of master data across the different applications. Say, this is a common problem for everyone, but it needs to be put on the table and addressed. So we have gone about in a very conventional manner as to any other organization does. We listed out as to what are all the masters which all the applications use, found only one single golden source of truth from the applications, use tools to migrate the consuming applications and then clean up the data. So and this is an exercise which needed to be undertaken by any organization which really wants to transform itself robustly. Similar to master data, you also have anomalies in data quality and data integrity. That is generic. And there is another problem of having two or more applications reporting on the same activity. So this is something which is again needs to be addressed at a very micro level in a systematic manner if you really want to transform a legacy system into something which is robust. And last but not the least, you have statistical systems, costing systems, and accounting systems which were hitherto in a manual mode. One way to judge the robustness of an IT system is to see whether you can generate all your statistics which are being generated, all your accounting statements which are coming, and all your costing systems, unit cost of operations, whether they can be derived out of your IT systems. And we have undertaken this journey in a very robust manner, and come maybe by August or September, we would have cracked most of them. These are the parameters which are normally used for costing. And I'm sure many of you would have done this exercise of costing by taking the expenditure granular levels. Our revenue and capital expenditure in the railway is categorized. You can take, say, from 3 lakh crores of revenue expenditure. It comes down in a nicely classified manner into the overtime incurred by a guard in, say, New Delhi depot. I mean, we are like any other organization, we have major heads, minor heads, sub-head, detailed, up to the PU level. And now when you cost, you need to take a physical parameter and distribute the cost for different services. And these are the parameters we use and challenge ourselves as to why each of them cannot come from our applications so that the costing is made robust. So that is on the application part. And similarly on the network, I mentioned to you that we have around 13,000 servers distributed in 5 data centers and disaster recovery. Here again, it has evolved over a period of time from the SDH links to MPLS, and then there are zones of responsibility, what we control, what the railways control, and how do you get the entire visibility into the system. The end user, if there is a failure, you need to get the systems into place in your NOC, which can tell you across all the 2.5 lakh endpoints, you should be able to pinpoint and say what exactly is lacking. Is it an application problem or is it a network link problem? And the network links go from tier 0 to tier 1 to tier 2 to tier 3. and the migration of the cloud. As we discrete systems, we are in a process of migrating and with 100% getting into the cloud management system. And last but not the least is on the cyber security and the operational efficiency tools. So here, traditionally, I mean, CRIS and its applications have been very strong like any other organization on the cyber security tools on the network side. That means you have your firewalls, intrusion prevention systems, and we have classified our, before you enter into our core systems for any transaction, you first need to get into a demilitarized zone, the militarized zone, and then you touch the actual systems. So we have been very traditionally very strong in architecting our networks, and here we try to map as to what are the tools we have. We are perhaps not very strong in the other areas, but now we are addressing them through a very systematic manner of identifying what are the tools we have in identity access, application, systems, and data, which basically the hardware security threats, network, and the endpoints. So we tried to find as to what are the tools we have in each of these buckets, which are shown in green, what are the tools we do not have, and what is it that we procure. We are procuring these yellow dots, and through an open tender, which we call for a security operations center. And the blue are some of the tools which we have but not functioning to the level what we want. And having said that, it is not just the security. You see the bottom half, the non-security tools are equally important in terms of having your testing tools, your load testing, your functional testing tools in place, your APM tools, so that you can find out as to which leg of this entire transaction things are going wrong. So we follow a very systematic method in terms of trying to evolve ourselves and make ourselves as a digitally very robust system. To get the entire hang of where we are going, this is the schematic we follow in terms of having discrete applications and the platform. There is a team which is dedicated to ensure that the master data management, transaction data, as well as what I mentioned about data quality, data integrity, which works to ensure that these applications, though evolved in a discrete manner, are actually seamless. Then we transport ourselves. I mean, we already had APIs earlier. Now an enterprise service bus links across these applications. And of course, once we have this ESB, we are now procuring something called a data warehouse, enterprise data warehouse. We already have data warehouse for different discrete applications. And on top of that, the BI. I mean, we are just now finished procuring BI. I mean, Click is in place for the next 3 years for us. And there is data lakes and MLOps for doing higher optimization, wherein we are about to award that shortly. So this is the entire landscape in which we look at it. Looks mind-boggling, but in a level it's very simple. But if you do it systematically, you can take it to a logical conclusion. Thank you very much.